Hi and welcome. I'm Victoria and I'm here today with my colleague Martin. We work as engineers in the NSO core team. And today we are here to tell you about an exciting new feature of NSO 5.5. Have you ever wondered what's the effect of your northbound request? Like how to correlate intent with changes applied to the network in an LSA deployment? And we have. And if you have as well, then this feature is definitely for you. Today, we are excited to introduce the concept of trace ID. A trace ID is assigned to a northbound request. Let it be netconf, restconf, JSON RPC, or a CLI request. If you already have a trace ID that you have used in your system northbound to NSO, pass it on as a commit parameter. NSO will use the trace ID you gave. If you don't want to provide a trace ID, there is no problem. NSO will generate one for you. Let's be clear. Trace ID is more than a transaction identifier. It is not another TID. If your northbound request involves multiple transactions, all transactions will share the same trace ID. Also, trace ID is propagated among NSO nodes, so you will see what was the overall effect of your request in an LSA cluster. Trace ID will appear in the northbound logs and in the network audit logs and in the device traces. It couples the intent with the changes applied to the network. Considering an LSA deployment, this means that the network audit log at the CFS layer have a unique, identifiable relation to individual device transactions at the RFS layer. So there will be logs decorated by trace ID, and that you can use to aggregate the log entries cluster-wide. From now on, you will have a cluster-wide view of what's happening, so you can better understand your system and have more platform support in carrying out audit tasks. But now you may ask, what if my northbound request triggered a reactive loop, like reactive fast map service or a nano service? In this case, the change derived from an intent is built up iteratively. And of course, we are curious of the overall effect. So we prepared Trace ID for this, so it does handle reactive services, which means that the same Trace ID will be assigned to all changes made by the service during its reactive progression loop. We thought as well that including Trace ID in your service debug logs may help you better understand your service. For this reason, there are getter functions that we provide and it's ready to use. So then you can retrieve Trace ID in your service code. Now you may wonder, what if I have commit queues? Well, no problem. Trace ID supports these scenarios. So we hope and we believe that using Trace ID, you will have a better understanding of your system and it will ease auditing tasks. We are really excited about it and hope you are as well. Now, next question will be how to use Trace ID in practice. Martin will show you now.
Thank you, Victoria, and hello everyone. My name is Martin, and as Victoria said, I work as a developer in the NSO core team. We have worked together on this new feature, and I'm going to talk through an example on how it can look in practice. For this example, we are using a fairly standard LSA setup with an upper NSO, a CFS, and 2 lower NSOs, 2 RFS, with a LSA aware service. And each of the lower NSO manages a number of devices separately, but in this case we are looking at the device X0 for the lower NSO1 and the device X5 for the lower NSO2. And we will see how we can use Trace ID to follow service intent in this setup. But first things first, how do we enable Trace ID? The short answer to that is that you don't need to, because this feature is enabled by default as of NSO 5.5. But the way to control it is in the ncs.conf file, where there's a new parameter under logs called Trace ID. This is default set to true, so if you want to disable it, you set it to false. And this is one global setting that turns this feature on or off. So you don't do this per log, you do this for the system. And if you enable it, all logs that support it will have it included in its headers. So this is an example from the CLI, how we set a number of set some configuration for a service on the top node, CFS node, and this will result in changes for the device X0 managed by NSO1 and device X5 managed by NSO2. We set these settings, the contents of them are not super relevant for this, so I don't want to go through them, and we commit it on the top node. As you see here, I don't provide a Trace ID. From the CLI, as well as the other northbound interfaces, it's possible to provide it here. If we would like to add it as a commit parameter here, it would simply be writing Trace ID after the commit and then filling in your own, whatever you want from perhaps your change management system or something else. And this will now be committed on the upper node, and we will be able to follow it in the LSA setup to the lower NSO and to devices managed by the lower NSOs. So the primary intended use case for this Trace ID, it appears in other places too, is in the Audit-network Log. This is a log file introduced in NSO 4.7, if I remember correctly. It gives you a condensed view of what changes NSO pushes to devices. So if you set something in a service, that results in a number of configuration changes on the devices themselves, you can use the Audit-network Log to get a condensed view of what changes are actually pushed to devices. And in the case of LSA setup, from the top node, top CFS node, the devices are of course the lower LSA nodes. So here we are looking at log headers from the Audit-network Log on the top NSO, the CFS node. And what we see here that's primarily interested is that we have the devices mentioned at the end, the device lower NSO1 for the top header and device lower NSO2 for the lower header. In between these, there would be a block showing exactly what changes are being pushed to the lower NSOs. We have excluded those details in this presentation. And you also see a Trace ID here. So the part in green here is part of each header in the Audit-network Log, as well as other logs, such as device traces. And as we did not provide this log ourselves here, you see a fairly random string here. And the interesting part here is, of course, that it is the same for both. We have one service intent going to 2 separate lower NSOs, and we have the same unique Trace ID. And some of you might think that the format of the Trace ID is familiar, and that's because this is fairly standardized. It's UUID version 4 format of this automatically generated Trace IDs. This is not required, of course, if you provided the Trace IDs yourself to NSO. So this was the upper NSOs. So these logs are the changes between the upper and the lower NSOs in LSA setup. If you look at the same log file, the Audit-network Log on the lower NSO1, after this log header that we look at here, we would see the actual device changes being pushed to the devices as a result of the service intent on the top node. And here you can see device X0, as that is the device that was managed by the lower NSO 1. And we see the same unique trace ID here, allowing us to trace the change from the top node all the way down to the device. Looking at the Audit-network log on lower NSO 2, we see a very similar log header here. But we see here, we are going towards the device X5, and the trace ID is the same, even though we are on different NSOs. So this has been propagated in the request between the nodes in the LSA setup, which is the intent here. Of course, similarly, if we would have provided the self, it would have been propagated in exactly the same way. So now I hand over back to Viktória, who is going to mention a bit about future work regarding this feature.
Yes, thank you, Martin. Right, because what we have shown you today is just the beginning of the road. We have many ideas how to go forward and give you more visibility. We would like to extend the support of Trace ID, add it to progress trace and commit log, so you will get much more insight in what is happening to your request. Or to include Trace ID in more log handlers to have a more complete picture of your system. Just listing now a few ideas, we have more, and we are super curious of your suggestions. Thank you very much for your attention. We hope you will find Trace ID useful, and we will take questions now.